there is a quiet assumption buried deep inside the way we think about human progress. It is the assumption that as time moved forward, as centuries accumulated and civilizations rose from the dust of older ones, human life must have steadily improved, that each generation woke to a slightly better world than the one their grandparents had known, that the arc of history bent gently upward, toward comfort, toward safety, toward longer, healthier lives. It is a reasonable assumption. It feels almost self-evident when you stand inside a modern city, surrounded by steel and glass and the hum of electrical systems. And yet, when we look carefully at the evidence left behind in bones and teeth and the microscopic traces of ancient settlements, something unexpected begins to emerge. Something that asks us to reconsider what we mean when we use the word progress. For most of the time that anatomically modern humans have existed on this planet, they did not live in cities. They did not live in villages. They did not even live in the small semi-permanent settlements that we sometimes imagine when we picture our ancient ancestors. For a vast and almost incomprehensible stretch of time, stretching back 200,000 years or more, human beings lived as mobile foragers. They moved through landscapes that were vast and varied. They slept where the ground was soft enough and the shelter sufficient. They ate what the land offered. And then, roughly 10,000 years ago, something began to shift. Agriculture arrived, slowly and unevenly, spreading across the world over thousands of years. With agriculture came settlements, with settlements came villages, and with villages eventually came cities. And it is here, at this point in the long, slow story of human civilization, that something remarkable, deeply counterintuitive happened. In many measurable biological ways, human health did not improve. It got worse. And in the medieval city, that decline reached a kind of grim and extraordinary depth. This raises a quiet question. How is it possible that the people who hunted animals across open savannas and gathered berries and roots in ancient forests, people without hospitals or written medicine or any of the institutions we associate with health, were in many ways biologically healthier than the merchants and craftsmen and priests who lived in the walled cities of medieval Europe? What does that tell us about the relationship between civilization and the human body? And what does it suggest about the long and complicated negotiation between our ancient biology and the environments we've built for ourselves? To begin to understand this, we need to travel back much further than the medieval period. We need to go back to the beginning, or at least to what we might reasonably call the middle of the beginning, to the long, slow era of the Paleolithic, the Old Stone Age, when our ancestors lived in small mobile bands and the world was nothing like the world we know. The human body, as it exists today, was shaped by millions of years of evolution in environments that bear almost no resemblance to the environments we now inhabit. This is one of the most important and most often overlooked facts about human biology. Our immune systems, our digestive systems, our cardiovascular systems, our sleep cycles, our stress responses, our skeletal structures, all of these were calibrated across vast stretches of evolutionary time to function in a particular kind of world, a world of open spaces and seasonal variation, a world of intermittent food and frequent movement, a world of small social groups and diverse diets, and intimate contact with the natural microbial communities of soil and plant and animal. The human body is, in the most literal biological sense, a Stone Age body. It carries within it the accumulated adaptations of ancestors who never saw a city, never breathed urban air, never drank water that had passed through the pipes and channels of a dense human settlement. And this matters enormously when we try to understand what happened to human health across the long arc of history. Because the transition from mobile foraging to settled agriculture, and then from small agricultural villages to dense urban centres, was not simply a change in lifestyle, it was a radical reorganisation of the biological environment in which the human body had to live. And the human body, shaped over millions of years for one kind of world, found itself suddenly required to function in a completely different one. If we look carefully at the skeletal remains of Paleolithic hunter-gatherers, what we find is often surprising to people who have not studied this subject. These were not frail or stunted creatures. The bones of Stone Age foragers tend to be dense and well-formed. Their teeth, when they survive in sufficient condition to be analysed, frequently show low rates of the kinds of decay and disease that are associated with high carbohydrate diets. Their stature, which can be estimated from long bones like the femur and the tibia, was often comparable to or even greater than the stature of people who lived in agricultural settlements thousands of years later. Bioarchaeologists, the scientists who study the biological evidence preserved in ancient human remains, have documented this pattern across many different regions and time periods. When populations shifted from foraging to farming, average height often declined. Average bone density often declined. The skeletal evidence for nutritional stress, things like enamel hyperplasia, which are horizontal lines, or bits in tooth enamel that form when growth is disrupted during childhood, became more common. The pattern is not universal, and there are important exceptions and regional variations, but it is consistent enough to constitute a genuine historical trend. Why would this be? Why would the shift to agriculture, which gave humans more reliable and abundant food supplies, have been associated with a decline in certain measures of health? The answer lies in the difference between variety and quantity. A mobile forager moving across a diverse landscape might eat dozens of different plant species in the course of a single month. Different roots and tubers, different leaves and seeds, different fruits and berries, each with its own particular profile of vitamins and minerals and phytochemicals. They would eat insects, which are extraordinarily nutritious. They would eat the organs of animals, the liver and kidney and marrow, which are dense with nutrients that are difficult to obtain from muscle meat alone. They would eat seasonal foods that varied across the year, providing different nutritional inputs at different times. This dietary variety, while it might seem chaotic compared to the structured meals of agricultural societies, was in fact a kind of nutritional insurance. It meant that deficiencies in one food source were likely to be compensated by abundance in another. The early farmer, by contrast, often depended heavily on a small number of cultivated crops. In many parts of the ancient world, this meant grains like wheat or barley or millet or maize. These crops could be stored and transported in ways that wild foods generally could not. They provided reliable calories, but they were nutritionally incomplete in ways that a varied foraging diet was not. A person who obtained most of their calories from grain was at risk of deficiencies in protein quality, in certain vitamins, in minerals like iron and zinc and calcium. The archaeological record reflects this. The bones and teeth of early agricultural populations often show the biological signatures of nutritional stress, in ways that the remains of their foraging predecessors frequently do not. But nutrition is only one part of the story. To understand why medieval cities were particularly devastating to human health, we need to understand the role of infectious disease. And to understand that, we need to understand something about the microbial world and the way the human immune system was shaped to interact with it. For most of human evolutionary history, our ancestors lived in small groups. Estimates vary, but the typical mobile foraging band probably consisted of somewhere between 20 and 50 individuals, with occasional gatherings of larger groups during seasons of abundance or for social and ceremonial purposes. These group sizes have profound implications for the dynamics of infectious disease. Many of the most dangerous infectious diseases that have shaped human history are what epidemiologists call crowd diseases. They're diseases that require a minimum population size to persist. Measles, for example, requires a community of many thousands of susceptible individuals to maintain continuous transmission. In a small mobile group, an outbreak of a highly contagious disease would either burn through the group and exhaust the supply of susceptible individuals, causing the chain of transmission to end, or it would kill enough people to fragment the group entirely. Either way, in the small band societies of the Paleolithic, the crowd diseases could not establish themselves as permanent features of the disease landscape. This does not mean that Paleolithic foragers were free of all disease. They faced parasites and infections of various kinds. They suffered injuries and faced the dangers of predators and harsh weather. Life was not easy or free of suffering. But the particular burden of highly contagious epidemic diseases, the diseases that would later devastate human populations in crowded settlements, was largely absent from the Paleolithic world. The human immune system evolved in an environment where certain kinds of microbial challenges were common and others were rare. It was well calibrated for the former and poorly calibrated for the latter, and this miscalibration would become increasingly significant as human populations grew denser and more settled. The shift to agriculture brought with it the domestication of animals. This was, in retrospect, one of the most consequential events in the history of human health. Living in close proximity to cattle, pigs, sheep, chickens, and other domesticated animals create conditions for the transmission of animal diseases to human populations. Many of the most important human infectious diseases have their origins in animal pathogens that made the jump to human hosts after the domestication revolution. Measles appears to have evolved from a cattle virus. Influenza has deep connections to birds and pigs. Smallpox shares ancestry with pox viruses found in domesticated animals. The dense, sedentary animal-keeping communities of early agricultural societies were, in effect, incubators for the emergence and spread of new infectious diseases. And then came the city. The city, in historical terms, is an extraordinary recent invention. The first true urban centres, with populations numbering in the tens of thousands, appeared in Mesopotamia roughly 5,000 years ago. By the standards of human evolutionary history, this is a vanishingly small slice of time. The cities of ancient Mesopotamia, of the Indus Valley, of early China and the pre-Columbian Americas were biological experiments of a kind that the human body had never before been asked to participate in. They brought together enormous concentrations of people, animals, waste and water in ways that created entirely new ecological niches for pathogens and parasites. And the cities of medieval Europe, which reached their fullest and most elaborate development in the centuries between roughly 900 and 1400 of the Common Era, represented in many ways the culmination of this process, a density of human biological vulnerability that the ancient world had rarely matched, and that would not be substantially improved until the development of germ theory and modern sanitation many centuries later. To understand the medieval city as a biological environment, it helps to begin with something simple. Water. Clean water is so fundamental to human health that it is difficult to overstate its importance. The human body is roughly 60% water. Nearly every biological process depends on adequate hydration and on the absence of harmful microorganisms in the water supply. In the Stone Age, a mobile foraging band moved frequently enough that their camps rarely accumulated enough human waste to contaminate local water sources. They drank from rivers and streams that had not been upstream of large human settlements. Their relationship with water, while not always safe by modern standards, was immeasurably better than what awaited the inhabitants of medieval cities. The medieval city had no modern water treatment, no understanding of germ theory, no concept of the relationship between contaminated water and disease. Water was drawn from wells, rivers and streams that were simultaneously used for the disposal of human and animal waste. In a city of even modest size, the concentration of waste near water sources was essentially unavoidable, given the technology and knowledge of the time. The famous descriptions of medieval European cities consistently reference the rivers of filth that ran through the streets, the open sewers, the piles of waste from households and slaughterhouses and stables. This was not simply a matter of aesthetic unpleasantness. It was a constant and deadly biological reality. Waterborne diseases like typhoid fever, cholera and dysentery were endemic in medieval urban environments. They killed children with particular efficiency because young immune systems are especially vulnerable to the bacterial and parasitic loads carried by contaminated water. A child born in a medieval city faced a gauntlet of waterborne pathogens from the moment they began to drink water drawn from urban sources. A child born into a mobile foraging band of the Stone Age, by contrast, would have grown up drinking water that was almost certainly cleaner in the most fundamental microbial sense. Not sterile, certainly, not treated or filtered in any modern way, but moving water from natural sources away from large accumulations of human waste carries a vastly lower load of the specific pathogens that are most dangerous to human health. This single difference in water quality accounts for a substantial portion of the difference in child mortality rates between Paleolithic foragers and medieval urban dwellers. But water is only one dimension of the story. Consider air. The human respiratory system evolved in environments where the air was, with the exception of occasional wildfires or volcanic activity, free of the dense particulate matter and biological pollutants that characterize densely populated human settlements. The medieval city was filled with smoke, from the hearth fires of individual homes, from the forges of blacksmiths and the kilns of potters and the ovens of bakers, from the burning of waste, from the constant combustion that was necessary to keep people warm and fed and supplied with the tools of daily life. In the narrow streets of a medieval city, where buildings often leaned toward each other overhead, creating something close to a tunnel effect, smoke and particulate matter could accumulate to levels that would be considered a public health emergency by modern standards. Chronic exposure to indoor and outdoor air pollution has well-documented effects on respiratory health. It damages the delicate tissues of the lungs, increases susceptibility to respiratory infections, and is associated with elevated rates of chronic lung disease. Medieval physicians did not understand the mechanism, but they were familiar with the symptoms. Respiratory illnesses, what they called various forms of the cough and the lung fever, were among the most common causes of illness and death in medieval European cities. The Stone Age forager, breathing the clean air of open landscapes, faced none of this particular respiratory burden. Their lungs, which were the same lungs we carry inside our own chest today, were operating in the environment they had evolved to function within. The medieval city dweller was asking those same lungs to perform in conditions they were profoundly ill-suited for. Then there is the question of crowding. The density of the medieval city, the closeness with which human bodies were packed together in homes and markets and churches and taverns, created ideal conditions for the transmission of airborne diseases. Tuberculosis, caused by a bacterium that spreads through the air when infected individuals cough or breathe, thrives in conditions of crowding and poor ventilation. The medieval city provided both in abundance. Archaeological and historical evidence suggests that tuberculosis was extraordinarily common in medieval European urban populations. Analysis of medieval skeletal remains from urban cemeteries frequently reveals the distinctive bone changes associated with tuberculosis infection. The disease left its marks not only on the lungs but on the spine and other bones, and these marks survive in the archaeological record to tell us something about the burden of suffering that urban medieval people carried within their bodies. A mobile foraging group of 20 or 30 people, living in the open air or in temporary shelters with excellent natural ventilation, presented a very different epidemiological environment for tuberculosis. The bacterium requires sustained close contact to spread efficiently. In a small band moving frequently across a large territory, the conditions for explosive transmission simply did not exist. This does not mean tuberculosis was entirely absent from Paleolithic populations. Evidence suggests it has ancient origins, but the scale of infection, the proportion of the population affected, the frequency with which it progressed to active and fatal disease, these would have been far lower in the dispersed, mobile societies of the Stone Age than in the crowded sedentary cities of the medieval world. If we look deeper into the biological experience of the medieval city, we encounter the flea. The small, unremarkable insect, which feeds on the blood of mammals and birds, played a role in medieval urban health that is almost impossible to overstate. The flea is the primary vector for the bacterium Yersinia pestis, the causative agent of plague. And plague in the medieval period achieved a scale of mortality that remains one of the most catastrophic events in the entire history of human infectious disease. The Black Death, which swept through Europe beginning in the 1340s, killed somewhere between 1/3 and 1/2 of the entire population of Europe within a few years. In some cities, mortality was even higher. Contemporary accounts describe cities in which the dead lay unburied in the streets, in which entire neighbourhoods were emptied of their inhabitants, in which the social fabric of centuries simply dissolved under the weight of mass death. The connection between plague and the conditions of the medieval city is not incidental. The rat population of a medieval city, sustained by the enormous quantities of food waste and organic material that accumulated in urban environments, provided a vast reservoir for Yersinia pestis. The fleas that lived on these rats could acquire the bacterium from infected animals and then transmit it to humans. The density of the medieval city, the intimate cohabitation of people and rats and fleas, the movement of infected fleas on the clothes and bodies of travellers and merchants, all of these created the conditions under which a pathogen like plague could achieve its staggering scale of destruction. The Stone Age forager did not live with this kind of relationship with rats. A small mobile band moving through the landscape did not accumulate the mountains of stored grain and organic waste that sustain large urban rat populations. The ecological relationship between humans and the rat, which is in many ways a relationship created by civilization itself, was essentially absent from the Paleolithic world, and without the rat reservoir, without the dense flea populations that the urban rat sustained, the particular nightmare of plague could not have existed in anything like the form it took in medieval cities. This is not to romanticize the Stone Age. The Paleolithic world had its own terrors and dangers. The risk of predation, the uncertainty of food supply, the dangers of injury and accident in environments without medical care, the vulnerability to weather and climate. These were real and sometimes fatal challenges that our ancient ancestors faced every day. Life expectancy at birth for Paleolithic foragers was certainly lower than for people living in modern developed countries, but this is largely because of very high infant and child mortality, driven by the dangers of childbirth and early childhood in the absence of modern medicine, not because of the chronic disease burden that devastated medieval urban populations. Those who survived childhood in Paleolithic societies may well have enjoyed a quality of physical health, measured in bone density and dental health and freedom from the chronic diseases of civilization, that would be enviable by medieval standards. The question of diet deserves extended consideration. The medieval city dweller ate a diet that was, by almost any nutritional standard, dramatically inferior to the diet of us Paleolithic forager. This is a conclusion that surprises many people, because we tend to associate the medieval period with abundance and variety, at least for the wealthy. And it is true that the medieval upper classes had access to a wider range of foods than the urban poor. But even for the nobility, the medieval diet was shaped by constraints and beliefs that had significant negative health consequences. And for the majority of urban inhabitants, the poor craftsmen and labourers and servants who made up the bulk of the city's population, the diet was often dangerously restricted. The staple food of the medieval European urban poor was bread made from wheat, or more often from cheaper grains like rye or oats, or a mixture of grains and legumes. Bread provided the majority of calories for most urban people. It was filling and relatively affordable. But a diet dominated by bread was nutritionally incomplete in ways that would have been biologically invisible to the people living it, but are clearly readable in the archaeological record. Vitamin C, which is found in fresh fruits and vegetables, was chronically deficient in the diets of many urban poor, particularly in winter when fresh produce was unavailable or unaffordable. Scurvy, the disease caused by severe vitamin C deficiency, was a real risk for urban populations who could not afford fresh food during the winter months. Rickets, caused by vitamin D deficiency, was common in children who spent their days in the narrow, shadow-filled streets of medieval cities with little exposure to direct sunlight. Iron deficiency anemia, which affects not only energy and cognitive function, but also immune competence, was widespread. The skeletal record of medieval urban populations is filled with the biological signatures of these deficiencies. The Paleolithic forager, moving through a diverse landscape and eating dozens of different plant and animal foods, was almost certainly not at risk of the particular nutritional deficiencies that plagued medieval urban populations. Fresh plant foods were consumed when available, providing vitamin C. Exposure to sunlight during outdoor activities provided vitamin D. The liver and marrow and organs of hunted animals provided iron and zinc and fat-soluble vitamins in forms that the body absorbs efficiently. The diet of a mobile forager was not abundant in calories by modern standards. There were lean seasons and times of hunger, but it was, in a profound nutritional sense, more complete than the bread, heavy diet of the medieval urban poor. Consider also the question of dental health. The human teeth evolved in the context of a diet that included a wide variety of plant and animal foods, but was low in the refined carbohydrates that promote the growth of cavity-causing bacteria. Stone Age teeth, when they have been well enough preserved for analysis, often show very low rates of dental caries. The diet of Paleolithic foragers, high in protein and fat and complex plant foods, did not provide the sustained feast of simple sugars that the oral bacteria responsible for tooth decay require. Medieval teeth, by contrast, frequently show extensive decay. The bread-heavy diet of urban populations and the availability of honey and increasingly of other concentrated sweeteners created exactly the conditions that oral bacteria thrive in. Dental abscesses and infections were common in medieval urban populations. Before the era of modern dentistry, a serious dental infection could spread to the jaw and skull and become life-threatening. Medieval skeletons from urban contexts often show the bone damage associated with dental infections that had progressed into the surrounding tissue. This is another dimension of the health burden that the medieval city imposed on its inhabitants. A burden that the Stone Age forager, with their low caries diet and their teeth worn by tough foods, but largely free of bacterial decay, would not have recognized. The role of physical activity deserves careful attention. The human body was shaped by evolution for a level of physical activity that is almost entirely foreign to the modern world, and was also substantially different from the activity patterns of many medieval urban dwellers. Hunter-gatherer studies in modern populations that still follow traditional foraging lifestyles have documented remarkable levels of daily physical activity. The Betkungsan people of southern Africa, the Hadza of Tanzania, and other foraging populations that have been studied by anthropologists typically walk enormous distances each day in the course of normal food acquisition. Hunting expeditions might cover 20 or 30 kilometers in a single day. Gathering activities involve sustained walking, bending, digging, and carrying. Children in foraging societies are in almost constant motion. The entire lifestyle is organized around movement in a way that modern sedentary life and even many forms of pre-industrial agricultural labor are not. This level of sustained physical activity has profound effects on cardiovascular health, metabolic function, bone density, immune function, and psychological well-being. The human cardiovascular system, calibrated by millions of years of evolution for high levels of daily movement, functions differently in a body that moves a great deal than in a body that does not. The metabolic processes that regulate blood glucose and insulin sensitivity are affected by activity levels in ways that have important implications for long-term health. The musculoskeletal system, designed to bear weight and move through space, maintains its structural integrity better under conditions of regular use. The medieval city dwellers' relationship with physical activity was complicated. Some medieval people, particularly agricultural labourers working in the fields surrounding cities, engaged in very high levels of physical work. But the urban craftsman, the merchant, the scholar, the priest, these individuals often led lives that were less physically active than either their agricultural counterparts or their Stone Age predecessors. The narrow streets of the medieval city, the sedentary nature of many crafts, the concentration of social life in indoor spaces, All of these factors shaped activity patterns in ways that were not always favourable to biological health. But the relationship between physical activity and medieval health goes deeper than simple levels of movement. It connects to another fundamental aspect of the human body's evolutionary design, the stress response. The human stress response, the fight-or-flight system mediated by hormones like cortisol and adrenaline, evolved in the context of acute physical threats, a predator, a rival group, a flood or fire. These were the stressors that shaped our stress response system over millions of years. The response is designed to mobilize energy quickly, heighten sensory awareness, prepare the body for intense physical action, and then return to baseline once the threat has passed. It is an acute response system, designed for brief intense activation followed by recovery. The stresses of the medieval city were different in important ways. The constant background anxiety of living in a place where epidemic disease could erupt at any moment, where economic precarity was a daily reality, where legal violence was a routine part of civic life, where the grinding poverty that characterized the lives of most urban inhabitants created a chronic, low-level physiological stress that the acute stress response system was not designed to handle. Chronic activation of the stress response, as modern research has clearly shown, has numerous negative effects on health. It suppresses immune function, increases inflammation, disrupts sleep, contributes to cardiovascular disease, and impairs cognitive function. The chronic background stress of urban medieval life created a physiological environment that was, in this respect, worse than the acute but episodic stress of the Paleolithic world. Let us turn now to something that is rarely discussed in conventional histories of health, but that is increasingly recognized as a fundamental dimension of human biology, the microbiome. The human body carries within it an extraordinary community of microorganisms, bacteria, fungi, viruses, and other microscopic life forms that inhabit the gut, the skin, the respiratory tract, and other body surfaces. This community, collectively known as the microbiome, is not merely a passenger in the human body. It is a functional partner in biological processes ranging from digestion to immune regulation to neurological function. The diversity and composition of the microbiome has profound effects on health, and the conditions under which humans live have profound effects on the microbiome. The Paleolithic forager lived in intimate daily contact with the soil and plants and animals of their environment. They dug roots from the ground with their hands. They handled animal carcasses. They slept on the ground. They moved through environments rich with diverse microbial communities. Their food was not sterile. It was prepared and consumed in ways that maintained regular exposure to the kinds of environmental microorganisms that the human immune system had evolved to interact with. This intimate relationship with the microbial world of the natural environment contributed, as modern research is beginning to suggest, to a rich and diverse gut microbiome that supported immune function and metabolic health in ways we are only beginning to understand. The medieval city, paradoxically, offered both too much and too little microbial contact. Too much, in the sense of constant exposure to pathogenic microorganisms through contaminated water, spoiled food, and the fecal-oral transmission routes that thrived in poorly sanitized urban environments. Too little in the sense of the diverse and beneficial environmental microbiome of soils and plants that the human immune system had evolved alongside. The urban microbiome was, in effect, a distorted version of the ancestral microbial environment, rich in pathogens, impoverished in the beneficial diversity that the human body had co-evolved with over millions of years. And this microbial impoverishment may have had consequences for immune function and overall biological resilience that contributed to the extraordinary disease burden of the medieval city. The question of sleep is another dimension that deserves careful examination. The human circadian rhythm, the internal biological clock that regulates sleep and wakefulness, evolved in the context of a world illuminated only by sunlight and fire. Our ancestors' sleep was anchored to the natural cycle of light and dark. They were active in daylight and rested when darkness fell, with the warm light of fire extending social activity for some hours into the evening, but not fundamentally disrupting the biological cues that governed sleep onset and duration. Research on contemporary foraging populations has suggested that traditional sleep patterns differ in interesting ways from the patterns typical in modern industrial societies. Rather than a single consolidated block of 7 to 8 hours, many traditional foragers appear to have sleep patterns that involve a first sleep in the early night, a period of wakefulness or light activity in the middle of the night, and a second sleep before dawn. The medieval city disrupted these ancestral sleep patterns in ways that had biological consequences. The bells of churches and monasteries marked the hours of the night and often woke sleepers. The noise of a dense human settlement, animals and people, and the sounds of commerce infiltrated even the quietest night hours. The cold and damp of medieval urban housing, which was often poorly insulated and adequately heated, interrupted sleep with the physiological discomfort of temperature extremes. The anxiety of living in a world of unpredictable epidemic disease and economic precarity contributed to the kind of chronic sleep disruption that modern research has shown to be profoundly damaging to immune function, metabolic health, and cognitive performance. The Paleolithic forager, sleeping in the open or in temporary shelters, closely attuned to the temperature and sounds of the natural environment, was not subject to the artificial disruptions of urban life. Their sleep, while not protected by the insulation and temperature control of modern housing, was embedded in a biological environment their sleep systems had evolved alongside. The sounds of nature, the cycle of firelight and darkness, the physical demands of a day of active movement, all of these contributed to a relationship with sleep that was, in important biological respects, more aligned with the body's evolutionary design than the fragmented and disrupted sleep of the medieval city dweller. The social environment of the medieval city deserves consideration as a dimension of biological health, because the social environment is not merely a backdrop to human life, but a direct influence on biological processes ranging from immune function to cardiovascular health to neurological development. The human being is a profoundly social animal, shaped over millions of years of evolution in small, tight-knit groups where social bonds were matters of literal survival. The quality of social relationships, the degree of belonging and social support and mutual trust, has measurable effects on biological health outcomes in ways that modern research is beginning to document with increasing precision. The social environment of the Stone Age band, for all its challenges and limitations, offered something that the medieval city often could not: intimate, sustained, lifelong membership in a small community where every individual was known to every other, where social bonds were deepened daily, where cooperation in the face of shared challenges created a sense of mutual belonging and collective purpose. This is not to idealize the social world of the Paleolithic, which had its own conflicts and hierarchies and cruelties, but the basic social architecture of the small foraging band, the scale of social life, the intimacy of relationships, the shared purpose of daily survival, were in important ways well matched to the social architecture of the human nervous system. The medieval city, by contrast, was a place of enormous social complexity and frequent social isolation. The anonymity of the urban crowd, the hierarchies of class and guild and ecclesiastical authority, the daily presence of strangers, the severing of the extended kinship networks that had sustained human social life for millennia, all of these created a social environment that was, for many of its inhabitants, profoundly disorienting. The urban poor of medieval Europe often lived in conditions of social fragmentation and economic precarity that created a form of chronic social stress quite unlike anything the Paleolithic world had offered. And this social stress, mediated through the same biological pathways as physical stress, contributed to the overall biological burden carried by medieval urban bodies. We should also consider the role of parasites. The human body's long coevolution with internal parasites, particularly intestinal worms and other helminths, is one of the more unsettling aspects of our biological history. Modern research in immunology has suggested that the human immune system evolved in the presence of these parasites, and that their absence from the modern environment may contribute to the elevated rates of autoimmune and allergic conditions seen in highly sanitized societies. This is a complex and contested area of science, but the basic observation is clear. The human immune system evolved in a world where intestinal parasites were a near universal feature of biological life. The Paleolithic forager almost certainly carried a burden of intestinal parasites, acquired through contact with contaminated soil and animal products. This was not beneficial in any simple sense, as parasites exact a real metabolic cost and can cause significant illness. But the immune system, trained over millions of years to coexist with these organisms, developed regulatory mechanisms calibrated to that chronic presence. The medieval city dweller, living in conditions of extraordinary sanitary squalor, carried an even heavier parasite burden than most Paleolithic foragers. Analysis of medieval latrines and the preserved intestinal contents of medieval human remains has revealed a startling diversity of intestinal parasites. Roundworms, whipworms, hookworms, tapeworms, flukes, and other helminths were essentially ubiquitous in medieval urban populations. But unlike the Paleolithic forager's parasite burden, which was acquired in a context of diverse diet and active movement that supported general biological resilience, the medieval city dweller's parasite burden was compounded by nutritional deficiency, chronic stress, and exposure to pathogenic bacteria and viruses through contaminated water. The result was a body fighting on multiple fronts simultaneously, with depleted nutritional reserves and a compromised immune system. The history of specific diseases illuminates this story in particularly vivid ways. Take tuberculosis. We've already touched on this disease, but it is worth examining in more detail because its history is a kind of mirror of the history of urban density itself. Tuberculosis is caused by Mycobacterium tuberculosis, a bacterium that is transmitted through the air when infected individuals cough or breathe. It requires sustained close contact for efficient transmission and thrives in conditions of overcrowding, malnutrition, and poor ventilation. The disease has ancient origins, and DNA from Mycobacterium tuberculosis has been found in prehistoric human remains, indicating that the bacterium or its ancestors were present in human populations long before the development of cities. But the evidence from skeletal remains suggests that tuberculosis became dramatically more prevalent as human populations became more densely settled. Medieval urban cemeteries, when analysed by modern bioarchaeologists, frequently reveal rates of skeletal tuberculosis that are far higher than those found in pre-agricultural or early agricultural populations. The progression from infection to active disease in tuberculosis is strongly influenced by nutritional status and immune competence. A well-nourished individual with a robust immune system may harbour the bacterium in a latent form for years or decades without developing active disease. A malnourished individual under chronic stress with a compromised immune system is far more likely to develop progressive, fatal tuberculosis. The medieval urban poor, malnourished and stressed and immunologically vulnerable, provided ideal conditions for the progression from latent to active tuberculosis. The Stone Age forager, with their more nutritionally complete diet and lower levels of chronic stress and different social density, would have been far less likely to develop active disease even if exposed to the bacterium. Consider also the skin. The skin is the largest organ of the human body, and its health is intimately connected to nutrition, hygiene, immune function, and the overall biological environment. The medieval city was, by modern standards, a place of extraordinary cutaneous hazard. The absence of soap that was affordable for the poor, the difficulty of bathing in a climate that was often cold, and in a city where clean water was scarce, the constant presence of lice and fleas and bedbugs in the fabric of everyday life, all of these created conditions in which skin diseases were rampant. Scabies, caused by a microscopic mite that burrows into the skin, was endemic in medieval European populations. Fungal infections of the skin and scalp, which thrive in conditions of warmth, moisture, and poor hygiene, were extremely common. The secondary infections that resulted from scratching at parasitic infestations, combined with the nutritional deficiencies that impaired wound healing, meant that what might have been trivial skin conditions in a healthy, well-nourished individual became serious and sometimes life-threatening problems for many medieval urban dwellers. The Paleolithic forager was not, of course, free of parasitic infestations. Head lice appear to have been a constant companion of our species since long before the advent of civilization, but the general biological resilience of the Stone Age body, supported by adequate nutrition and physical activity and a robust immune system calibrated to its environment, meant that the consequences of parasitic exposure were often less severe, and certain parasites that thrived specifically in the dense, sedentary, filth-accumulating conditions of the medieval city were simply not present in the dispersed, mobile world of the Paleolithic. The role of food preservation and contamination in medieval urban health is another dimension worth examining. The medieval city required food to be transported and stored in ways that introduced significant risks of contamination and spoilage. Grain stored in damp conditions could become infected with ergot, a fungal parasite that produces alkaloids with powerful psychoactive and vasoconstrictive effects. Ergotism, the disease caused by consuming ergot-contaminated grain, produced symptoms ranging from convulsions and hallucinations to gangrene of the extremities caused by constriction of blood vessels. Outbreaks of ergotism, documented repeatedly in medieval Europe, could affect large numbers of people simultaneously, particularly in poor urban populations dependent on cheap grain. The Stone Age forager, eating fresh foods as they were gathered rather than stored grain, was not subject to the risks of ergot contamination. Salmonella and other bacteria that cause food poisoning thrived in the medieval city's conditions. Meat and other perishable foods sold in open markets without refrigeration in conditions that varied dramatically with the season carried substantial microbial loads. The medieval practice of using salt and spices to preserve and mask the taste of partially spoiled meat was not always sufficient to prevent illness, and in a population already weakened by nutritional deficiency and chronic disease burden, a bout of food poisoning that a healthy person might survive with discomfort could become fatal. Foodborne illness, while not always recorded in historical sources, was almost certainly a significant contributor to the mortality load of medieval cities. The relationship between medieval cities and lead deserves specific mention. Lead pipes and lead-lined vessels were used extensively in medieval water systems, particularly in more prosperous urban areas that had invested in infrastructure. Roman lead plumbing systems, inherited and maintained by medieval European cities, introduced lead into the water supplies of many of the most developed urban centres. Lead accumulates in the body over time and has devastating effects on neurological development and function, immune competence, reproductive health, and cardiovascular function. Analysis of medieval skeletal remains from urban contexts has frequently revealed bone lead concentrations that would be considered indicative of serious lead toxicity by modern standards. This chronic low-level lead poisoning, affecting particularly children whose developing brains and bodies are especially vulnerable to lead, would have contributed to cognitive impairment and immune dysfunction in ways that compounded all the other health burdens of the medieval city. The Paleolithic forager, living in a world without lead plumbing or lead-glazed pottery or the other sources of anthropogenic lead contamination that characterized urban environments, had skeletal lead concentrations that were orders of magnitude lower than those of medieval urban dwellers. This is another dimension in which the comparison between the Stone Age and the medieval city reveals something profound and somewhat disturbing about the relationship between civilization and biological health. There is also the question of childhood specifically. The health of children is in many ways the most sensitive indicator of the overall biological health of a society, because children are most vulnerable to the particular challenges of the environments they inhabit. The child mortality rates of medieval European cities were extraordinarily high by any standard. In a typical medieval city, somewhere between 1/3 and 1/2 of all children born alive would die before reaching adulthood. The diseases and nutritional deficiencies and environmental hazards we've been examining throughout this story took their greatest toll on the youngest and most biologically vulnerable members of urban communities. Ecological studies of medieval urban cemeteries have revealed the particular biological suffering of medieval children in moving detail. Small skeletal remains show the bone lesions and growth disruptions and dental defects that are the physical marks of chronic nutritional deficiency and repeated infectious illness. The bones of medieval urban children often show evidence of multiple overlapping episodes of physiological stress, each one leaving its permanent record in the structure of bone and tooth. These are the biological signatures of childhoods, spent in a relentless biological struggle against an environment that was, in multiple simultaneous ways, hostile to human health. Compare this with what we know and can reasonably infer about childhood in Paleolithic foraging societies. The skeletal remains of children from pre-agricultural contexts, while not abundant enough to permit the kind of systematic analysis possible for medieval populations, generally show lower rates of the specific markers of nutritional deficiency and infectious disease burden. The foraging child grew up in the open air, under direct sunlight that provided vitamin D, eating a varied diet that included animal foods and diverse plant species in a social group where they were known and nurtured by every adult member, the risks they faced were real and significant. Injury, predation, exposure, the dangers of childbirth affecting their mothers were all present. But the specific biological degradation associated with urban poverty and urban disease burden was absent. To understand the full scale of the contrast between Stone Age and medieval health, it is useful to consider the concept of the ecological niche. Every organism has an ecological niche, a set of environmental conditions within which it functions optimally. Remove an organism from its niche, and its biological performance degrades. The human body evolved within the ecological niche of the mobile forager, the open landscape, the seasonal variation of temperature and food availability, the small social group, the diverse diet, the high physical activity, the intimate contact with the natural microbial world. That niche is where our biology is calibrated to function. The medieval city was, from the perspective of human evolutionary biology, about as far from that original niche as it is possible to imagine while remaining nominally recognizable as an environment for human life. Dense, crowded, contaminated, nutritionally impoverished for most of its inhabitants, cut off from the natural microbial diversity of the landscape, filled with novel pathogens and new forms of environmental stress. It is not simply that the medieval city was less healthy than the modern city. It is that the medieval city represented a kind of extreme biological displacement, a radical departure from the conditions in which the human body had evolved, without any of the technological compensations that would eventually make dense urban life tolerable and then genuinely healthy. This is a point that requires careful philosophical unpacking, because it is easy to misread the comparison between Stone Age and medieval health as a simple argument for primitivism or a rejection of civilization. It is neither. The development of cities, of agriculture, of the accumulated knowledge and technology that made urban life possible, was in the long arc of human history a process that would eventually lead to the extraordinary improvements in health and longevity that we take for granted in the modern world. The agricultural revolution and the urban revolution created the conditions for the development of medicine, of sanitation science, of germ theory, of vaccination, of all the tools that have allowed modern humans to dramatically reduce child mortality and infectious disease burden and live longer and healthier lives than any previous human population. But that eventual achievement should not blind us to the very real biological costs of the intermediate phases of this process. The medieval city was, in a very real sense, a biological experiment that was not yet working. The knowledge needed to make dense urban life genuinely healthy, knowledge about germs and sanitation and nutrition and epidemiology, did not yet exist. And in the absence of that knowledge, the concentration of human bodies in dense settlements created a biological environment that was, by multiple measurable standards, worse for human health than the dispersed, mobile, nutritionally varied lifestyle of the Stone Age forager had been. The medieval city was the biological trough of human history, the point at which the gap between the environments humans were evolved for and the environments humans were creating for themselves was perhaps widest. It is worth dwelling on what this means philosophically. Progress in the narrative we tell ourselves about history is supposed to move in one direction. Each generation is supposed to pass to the next a world that is in some measurable way improved. The agricultural revolution is supposed to have been an improvement over hunting and gathering. The city is supposed to have been an improvement over the village. And in some ways, of course, both of these things were true. Agriculture provided more reliable calories. Cities provided concentrations of specialized knowledge and craft and culture that no dispersed foraging society could match. The great cathedrals, the universities, the guilds, the systems of law and governance that medieval cities supported, these were achievements of real significance. But they were achieved at a biological cost that is only legible when we look at the bones and teeth and the microscopic traces of ancient pathogens preserved in archaeological sites. From an evolutionary perspective, the medieval city was an extraordinary biological challenge. And the remarkable thing is not that so many people died in medieval cities. The remarkable thing is that the cities continue to exist and grow, despite the extraordinary death rates they imposed on their inhabitants. Medieval cities were, in the technical demographic sense, population sinks. They consumed people faster than they produced them. They could only maintain their populations through constant immigration from the countryside, from the agricultural villages that supplied a steady flow of young, relatively healthy individuals who would be exposed to the full biological assault of the urban environment. This is a pattern that historians and demographers have documented repeatedly in pre-industrial urban history. The city drew people from the countryside with the promise of economic opportunity, social excitement, and the concentrated cultural life that only urban density could provide, and it consumed them in biological terms at a rate that no pre-industrial city could sustain from its own reproductive population alone. The Stone Age forager, by contrast, lived in what modern demographers would recognise as a relatively stable population ecology. Birth rates were not dramatically higher than death rates. The population grew slowly over thousands of years, constrained by the carrying capacity of the landscapes through which bands moved, and by the same high infant mortality that characterised all pre-modern populations. But the specific driver of death in the foraging band was different from the driver of death in the medieval city. In the foraging band, the primary mortal risks were concentrated in infancy and early childhood, in the dangers of childbirth, in acute traumatic injury, and in the occasional catastrophic failure of food resources. Once a person survived childhood and established themselves as a functional member of the band, their biological resilience and the relative absence of the chronic disease burden that characterized urban life gave them a reasonable prospect of reaching what we might call the functional end of biological life, the point at which accumulated, age-related deterioration became incompatible with the demands of the foraging lifestyle. There is a concept in anthropology sometimes called the healthy survivor effect, the observation that individuals who survive the gauntlet of childhood in harsh environments often display remarkable resilience in adulthood. The Stone Age forager who survived childhood was, in a very real sense, a biological success story, a person whose immune system had been tested and strengthened by exposure to the microbial challenges of the natural environment, whose musculoskeletal system had been built into robust functionality by years of physical activity, whose metabolic systems had been calibrated to function well in conditions of dietary variety and occasional scarcity. The medieval urban survivor of childhood was a very different kind of biological entity. The immune system had been taxed and often compromised by the multiple, simultaneous infectious challenges of the urban environment. Their nutritional status had been impaired by the inadequate and unvaried diet of the urban poor. Their skeletal structure bore the marks of childhood illnesses and nutritional deficiencies in ways that would affect their biological function throughout their adult lives. The contrast between these two kinds of biological trajectory, the Stone Age forager and the medieval city dweller, is one of the most compelling arguments for taking evolutionary biology seriously as a framework for understanding human health. We are not, in our biology, creatures of any particular historical period. We are creatures of a deep past that extends back millions of years, before the first city was built, before the first grain was sown, before the first domesticated animal was penned. Our bodies carry the evolutionary legacy of that deep past in every cell and system, and the degree to which the environments we create for ourselves align with or diverge from that evolutionary legacy has enormous consequences for our biological health and well-being. The medieval city diverged from that legacy in almost every possible dimension simultaneously. Its water was contaminated, its air was polluted, its food was nutritionally impoverished for most of its inhabitants. Its social density facilitated the transmission of infectious diseases for which the human immune system had no prepared defense. Its microbial environment was distorted in ways that undermined immune function. Its relationship with the natural world was severed in ways that deprived the human body of the environmental inputs it still evolved to depend on. It is, in retrospect, almost miraculous that the medieval city worked at all, that it produced cathedrals and universities and legal systems and guild structures, and the accumulated cultural achievements that we rightly celebrate as part of the heritage of human civilization. It achieved all of this against a backdrop of biological suffering that we can only fully appreciate now, centuries later, when we have the tools to read the evidence left in bones and teeth, and the microscopic traces of ancient pathogens. And yet the medieval city was not simply a mistake or a tragedy. It was a necessary phase in a longer process. The insights that eventually made urban life genuinely healthy, the germ theory of disease, the principles of sanitation and public health, the understanding of nutrition, the development of vaccines and antibiotics, all of these emerge from the accumulated intellectual tradition that was built, paradoxically, within and through the urban cultures that paid such a high biological price for their existence. The university, the library, the network of literate scholars communicating cross distances. These were the cultural technologies that eventually produced the biological revolution we call modern medicine. They could not have existed without the city, and the city in its pre-industrial form could not exist without imposing the biological costs we've been examining. This is perhaps the deepest philosophical insight that emerges from the comparison between Stone Age and medieval health. Progress is not linear. It does not move in a smooth, unbroken arc from worse to better. It moves in complex trajectories that sometimes require biological regression in order to achieve cultural advances that will eventually enable biological improvement. The medieval city was, in biological terms, worse than the Stone Age. In cultural terms, it was the precondition for everything that came after. Both of these things are simultaneously true, and holding them in tension is essential to understanding the full complexity of the human story. There is one more dimension of this comparison that deserves careful exploration: the psychological and cognitive experience of health. Modern research in health psychology and psychoneuron immunology has established beyond reasonable doubt that psychological states have direct biological effects. Chronic stress, Depression, anxiety, social isolation, feelings of helplessness and lack of control over one's circumstances. All of these have measurable negative effects on immune function, cardiovascular health, wound healing, and the progression of infectious and chronic diseases. The mind and the body are not separate systems, they are deeply integrated, and the psychological environment in which a person lives has biological consequences that are as real as the effects of diet or physical activity. The psychological environment of the medieval city was, for most of its inhabitants, one of pervasive uncertainty and frequent terror. The possibility of epidemic disease erupting without warning and killing half the people one knew. The precariousness of economic survival in a world without social safety nets. The omnipresence of legal violence, from public executions to the casual brutality of the powerful toward the powerless. The theological atmosphere of a culture that taught that disease and suffering were punishments for sin, creating a framework of guilt and self-blame that compounded the psychological burden of illness. The sense of powerlessness in the face of forces, biological, political, economic, meteorological, that were both devastating and incomprehensible. The psychological world of the Paleolithic forager was also not free of fear or uncertainty. The dangers of predation and injury, the uncertainty of food availability, the losses of loved ones to accident and illness, all of these were real and emotionally significant. But there is a meaningful difference between the acute fear of a specific, identifiable threat and the chronic, diffuse anxiety of living in an environment where invisible forces can strike at any moment without warning or comprehensible pattern. The forager's fears were largely specific and often resolvable through action. The hunter could deal with a predator by fleeing or fighting. The band could respond to food scarcity by moving to a different territory. The psychological stresses of Paleolithic life were, in many cases, amenable to the kinds of active responses that evolution had equipped the human psyche to make. The stresses of the medieval city were different. You could not flee the plague by running. You could not fight the contaminated water by physical action. You could not resolve the chronic anxiety of poverty by any individual act of will or skill. The stresses were systemic and environmental and therefore largely outside the individual's control. And this chronic, unresolvable, systemic stress imposed a psychological and therefore biological burden on medieval urban populations that was, in important ways, more damaging than the more acute but more resolvable stresses of Paleolithic life. As we approach the end of this long, slow exploration of a counterintuitive historical truth, it is worth returning to the question with which we began. How is it possible that people who hunted and gathered in an ancient world without medicine, or written knowledge, or the institutions of civilization were, in many biological ways, healthier than the inhabitants of medieval cities? The answer, as we've seen, is both simple and complex. Simple in that it rests on a single foundational insight. The human body is a Stone Age body, evolved for a Stone Age world, and the further the environments in which it must live diverge from that original world, the more its biological performance degrades. Complex in that the ways in which the medieval city diverged from the Stone Age world were multiple and interconnected and mutually reinforcing, creating a biological environment that was, in its totality, profoundly hostile to the health of the bodies that inhabited it. The story of human health is, in this sense, a story about the fit or misfit between the biological systems that evolution built and the environments that human culture creates. For most of human history, the culture humans created the simple technologies and social structures of the mobile foraging band was closely enough aligned with the evolutionary legacy of the human body that the two systems could function reasonably well together. With the agricultural revolution, and especially with the rise of dense urban settlements, that fit began to break down in ways that would take millennia to repair. The medieval city represents the moment of maximum misfit. The city of the 15th century European world, with its contaminated water and polluted air, and nutritionally impoverished food systems and epidemic diseases and lead plumbing and psychological burden and social fragmentation, was asking the Stone Age body to do something it had not been designed to do. And the body remarkably managed. Not well by any biological standard, but it managed. It produced children, however many of them died. It maintained social structures, however costly in biological terms. It built cathedrals and universities and legal codes and the accumulated cultural inheritance that would eventually produce the knowledge needed to make the city genuinely livable. This is, in the quietest possible sense, an extraordinary story. The story of a biological organism that created environments profoundly hostile to its own health, and then, through the cultural tools these environments made possible, eventually found the knowledge to repair the damage. The story of the human body navigating its way through the Stone Age, and the agricultural revolution, and the urban revolution, and the industrial revolution, and the public health revolution. Each phase imposing new biological challenges, and each phase eventually generating the cultural responses that addressed, at least partially, the challenges of the previous one. We are still in the middle of this story. The modern city, with its clean water and sanitation systems and vaccines and antibiotics and nutritional science, is immeasurably healthier than the medieval city. But the modern city is still, in important ways, a misfit with the Stone Age body that inhabits it. The rates of chronic diseases associated with sedentary behaviour, with nutritional excess and imbalance, with sleep disruption and chronic stress and social fragmentation, with microbial impoverishment and the severing of our relationship with the natural world. All of these remind us that the negotiation between the Stone Age body and the modern environment is not yet complete. Perhaps the most important insight that emerges from the long, slow comparison between Stone Age health and medieval urban health is this: the human body is remarkably resilient and remarkably fragile at the same time. Resilient in its ability to adapt over both evolutionary and developmental timescales to a remarkable range of conditions. Fragile in its dependence on a specific set of biological inputs, the inputs for which it was evolutionarily calibrated for optimal function. Understanding this tension between resilience and fragility, between the body's remarkable adaptability and its deep dependence on conditions that the modern world often fails to provide, is one of the most important tasks of contemporary biology, medicine, and public health. The bones of Stone Age foragers, dense and well-formed, bear witness to the extraordinary biological achievement of a lifestyle calibrated over millions of years to the needs of the human body. The bones of medieval city dwellers, marked by the signatures of nutritional deficiency and infectious disease and chronic stress, bear witness to what happens when civilization moves faster than biology can follow. Both sets of bones are speaking to us across the centuries. Both are telling us something profound about who we are, where we came from, and what our bodies need to function at their biological best. And perhaps in the quiet hours of the night, when the noise of the city fades and the darkness outside is as deep as it was on any Paleolithic evening, it's worth listening to what they have to say. To understand this fully, we need to examine something that is often overlooked in discussions of medieval health, the specific architecture of the medieval city itself, and how the physical structure of the built environment shaped the biological experience of its inhabitants in ways that went far beyond the obvious problems of sanitation and overcrowding. The medieval city was not designed by anyone with health in mind. It grew organically, incrementally, building upon itself in layers that accumulated over centuries without any overarching plan or vision of what a healthy human settlement might look like. Streets follow the paths of ancient tracks and the contours of the land. Buildings were constructed wherever space permitted, often encroaching on the narrow lanes that were the arteries of urban life. And the result was a physical environment that was, from a biological standpoint, almost perversely hostile to human health in ways that extend well beyond the obvious and well-documented problems of water contamination and disease transmission. Consider sunlight. The human body requires ultraviolet radiation from sunlight to synthesize vitamin D, a compound that is essential not only for bone health but for immune function, cardiovascular health, neurological function, and a range of other biological processes that modern research is still cataloguing. The human skin evolved to synthesize vitamin under conditions of regular sun exposure are the latitudes where our species spent most of its evolutionary history, in the tropics and subtropics of Africa. As human populations migrated to higher latitudes, where sunlight is less intense and the winter sun is too low in the sky to trigger vitamin D synthesis, they evolved lighter skin pigmentation to compensate. But even lighter skin requires meaningful exposure to direct sunlight to synthesize adequate amounts of vitamin D. In the narrow shadowed streets of a medieval city, particularly in the northern European cities where the sun angle was already low for much of the year, meaningful sun exposure was difficult to obtain. Buildings rose 2, 3, sometimes 4 stories, blocking the sky above the streets. The upper floors of buildings jutted out over the lower floors in the characteristic jettying construction that's still visible in surviving medieval buildings in places like York and Bruges. The result was that the ground level of a medieval city street received very little direct sunlight, even on the brightest summer days. Workers and craftsmen and market vendors who spent their days in these shadowed streets, and children who played in them, received far less vitamin D producing sun exposure than either their agricultural counterparts in the surrounding countryside or their Paleolithic ancestors moving through open landscapes under unobstructed skies. The biological consequences of this chronic sun deprivation were substantial. Rickets, the bone deformation disease caused by vitamin D deficiency in childhood, was endemic in medieval European cities. Medieval skeletal collections from urban sites show rates of rickets that would be considered a public health emergency by modern standards. The characteristic deformations of rickets, the bowed legs, the thickened wrists and ankles, the flattened pelvis that made childbirth more dangerous for affected women, appear with striking frequency in medieval urban skeletal samples, and with much lower frequency in rural and certainly pre-agricultural skeletal populations. The rickets epidemic of the medieval city was, in essence, a sunlight deficiency epidemic, and it was a direct consequence of the physical structure of the urban built environment. Beyond rickets, the broader effects of vitamin D deficiency on immune function meant that medieval city children were fighting infections with compromised biological resources. Vitamin D plays a crucial role in the function of the innate immune system, the body's first line of defense against pathogens. Deficiency impairs the ability of immune cells to respond effectively to bacterial and viral challenges. Children raised in the shadowed streets of medieval cities, with vitamin D levels chronically depressed by inadequate sun exposure and further compromised by the dietary deficiencies we've already examined, were immunologically vulnerable in ways that compounded every other biological challenge they faced. The Stone Age forager, ranging across open landscapes under direct sunlight for much of the day in the course of normal food-gathering activities, had no such problem. Their vitamin D levels, even at higher latitudes, would have been supported by the substantial sun exposure that came with an outdoor lifestyle. The foraging life was, among other things, an outdoor life. And the outdoor life, in this fundamental biochemical sense, was a healthier life than the indoor, shadow-dwelling life of the medieval city. We should also consider the question of iron more carefully, because the relationship between iron status and health in medieval urban populations is particularly illuminating. Iron is essential for the production of hemoglobin, the molecule that carries oxygen in red blood cells. Iron is also critical for immune function. Deficiency of iron produces anemia, with effects ranging from fatigue and cognitive impairment to increased susceptibility to infection and impaired physical development in children. The signs of iron deficiency anemia can be seen in skeletal remains in the form of a condition called cribrat or batalia, porous lesions on the roof of the eye socket, and similar lesions on the outer surface of the skull called porotic hyperostosis. Both conditions reflect the bone marrow's response to chronic anemia, expanding its blood-producing capacity in ways that leave permanent marks on bone structure. Studies of medieval urban skeletal populations reveal rates of cribra or batalia and porotic hyperostosis that are significantly higher than those found in pre-agricultural skeletal samples. This pattern is not uniform and varies by region, time period, and social class, but the general trend is clear and consistent. The dietary dependence on grain rather than on the diverse animal and plant foods of the foraging diet contributed to this pattern in several ways. Plant foods contain a form of iron called non-heme iron that is absorbed less efficiently by the body than the heme iron found in meat, particularly red meat and organ meats. A diet rich in grain and poor in animal products therefore delivers less bioavailable iron than the mixed diet of the forager. Furthermore, certain components of grain, particularly phytic acid, actually inhibit the absorption of iron and other minerals, reducing the nutritional value of the grain even further in this respect. The poor of the medieval city, living almost entirely on bread and other grain-based foods with occasional small amounts of animal products, were particularly vulnerable to the cumulative effects of this dietary iron deficiency. The Paleolithic diet, rich in meat including organ meats and bone marrow, provided iron in highly bioavailable forms and in substantial quantities. The hunter who participated in the killing of a large game animal and the distribution of its parts among the band was receiving a nutritional input in terms of iron and zinc and vitamin B12 and other nutrients found in animal foods that the medieval city dweller dependent on bread simply could not match. This is not an argument for any particular modern dietary philosophy. It is simply an observation about the relationship between the nutritional profile of different historical diets and the biological health indicators preserved in the archaeological record. Let us turn now to a dimension of health that is less often discussed, but that is, in many ways, the most fundamental of all: the relationship between the human body and the landscape it inhabits. This relationship is not merely metaphorical or spiritual, it is biological, in the deepest sense. The human body evolved in intimate contact with the soils, plants, waters, and microbial communities of natural landscapes, and this contact shaped biological systems in ways that are only now being fully appreciated. Modern research in immunology has produced a body of findings that is sometimes grouped under the umbrella of the biodiversity hypothesis or the old friends hypothesis. The central idea is this: the human immune system evolved in the presence of a rich community of microorganisms and parasites from the natural environment, bacteria from soil, worms and other parasites from the landscape, diverse microbial community from fermented foods and water drawn from natural sources. This chronic, diverse microbial exposure served as a kind of ongoing calibration for the immune system, training it to distinguish between genuinely dangerous pathogens and harmless environmental microorganisms, and tuning the regulatory circuits that prevent the immune system from attacking the body's own tissues. The mobile forager, ranging across diverse landscapes, digging in soil, drinking from streams, handling animal carcasses, eating a wide variety of plant and animal foods in various states of processing, was in continuous contact with exactly this kind of diverse microbial community. Their immune systems were being constantly calibrated by the rich microbial world of the natural environment. This calibration was not always pleasant or without cost. Parasitic infections could cause real illness. Exposure to certain environmental bacteria could cause acute infections. But the overall effect of this diverse microbial exposure over evolutionary time and over the developmental time of individual lives was the establishment of a well-calibrated immune system that was neither hypersensitive nor inadequately responsive. The medieval city, as we've noted, offered a distorted version of this microbial world. Its citizens were exposed to enormous quantities of pathogenic microorganisms through contaminated water and food and the fecal-oral transmission routes that thrived in the urban environment. But this exposure was qualitatively different from the diverse environmental microbial exposure of the forager. It was an exposure dominated by pathogens, by harmful bacteria and viruses, rather than the diverse community of mostly harmless and often beneficial environmental microorganisms that the immune system had evolved alongside. The medieval city dweller's immune system was being challenged in exactly the wrong way. Overwhelmed with pathogenic challenges from contaminated water and food, while simultaneously deprived of the regulatory microbial exposures that came from intimate contact with natural soils and diverse plant communities and the broader microbial world of the landscape. This microbial impoverishment had consequences that extended beyond simple immune function. The gut microbiome, as modern research has revealed, plays a role in biological processes ranging from the digestion of certain nutrients to the regulation of inflammatory responses to the production of neurotransmitters that influence mood and cognitive function. A gut microbiome shaped by the contaminated, monotonous diet of the medieval urban poor, deficient in the diverse plant fibers and fermented foods and environmental microbial inputs that sustain a healthy microbial community, was not functioning at its biological optimum. This was not something medieval physicians could have recognized or measured, but it was real, and it contributed to the overall biological degradation that characterized urban medieval health. The history of specific epidemic events in the medieval period provides concrete illustration of the cumulative biological vulnerability we have been examining. The Black Death of the 1340s is the most famous and most dramatic, but it was neither the first nor the last major epidemic to devastate medieval European cities. The 14th century was in fact a period of extraordinary epidemiological catastrophe, with plague returning in multiple waves following the initial outbreak of 1347 to 1353. Each successive wave found a population that was already weakened by the losses of the previous wave, with fewer experienced farmers and craftsmen and the social disruption that follows mass mortality. But even before the Black Death, medieval European cities had experienced repeated devastating epidemics. What medieval chroniclers called the sweating sickness, the burning fever, and various forms of plague had struck urban populations throughout the high medieval period. The population growth of the 12th and 13th centuries, which had created the dense urban centres that characterised the high medieval period, had also created the biological conditions for epidemic disease on an unprecedented scale. When the Great Famine of 1315 to 1322 struck northern Europe, killing millions through starvation and the infectious diseases that exploit malnourished populations, it did so in a world that had been building toward biological catastrophe for generations. The Great Famine and the Black Death together constitute what historians sometimes call the 14th century crisis, a period of demographic and social collapse that reduced the population of Europe by perhaps 1/3 to 1/2. And while the immediate causes of these catastrophes were a complex climate event in the case of the famine and a novel pathogen in the case of the plague, the biological vulnerability that made their consequences so devastating was the product of centuries of accumulated health degradation in the dense urban settlements of medieval Europe. A population that was well nourished, with robust immune systems and diverse gut microbiomes, and adequate vitamin D and good quality sleep and moderate levels of physical activity and clean water, would not have survived plague without casualties, because Yersinia pestis is extraordinarily lethal even in ideal biological conditions. But the extraordinary mortality rates of the Black Death, which exceeded 50% of the population in some areas, reflect the compounding of pathogen lethality with an extraordinarily compromised host population. Consider what those mortality rates mean in human terms. In a village or neighbourhood where half the people died within a few months, the social fabric did not simply fray. It disintegrated. Children were left without parents. Fields went unplanted and unharvested. The skilled craftsmen and farmers and administrators who maintained the complex systems of medieval, agricultural and urban society died before they could pass their knowledge to the next generation. The psychological trauma of mass death on this scale is difficult to comprehend from a modern perspective. Contemporary accounts describe communities in which the normal rituals of death and burial simply collapsed under the weight of the numbers, where bodies were buried in mass graves without the religious rites that medieval society considered essential for the soul's passage, where the living were too few and too frightened to properly attend to the dead. This was a civilization experiencing a biological crisis of existential proportions. And yet, the Paleolithic world, despite lacking any of the cultural and technological achievements of medieval civilization, would almost certainly have been spared this particular catastrophe. Not because Yersinia pestis did not exist in the Paleolithic world. Ancient DNA analysis has found evidence of the bacterium in skeletal remains from the Bronze Age, and it may be even older. But the ecological conditions for plague at the scale of the Black Death, the vast rat populations of the medieval city, the dense human population providing an ideal environment for flea-to-human transmission, the trade routes along which infected fleas and their hosts could travel rapidly across thousands of miles. None of these conditions existed in the dispersed, mobile pre-agricultural world of the Stone Age. The pathogen was there. The biological conditions for catastrophe were not. This point about trade routes deserves expansion, because it is one of the ways in which the interconnected world of medieval civilization created biological vulnerabilities that had no parallel in the Stone Age. The medieval world, by the time of the Black Death, was more economically interconnected than any previous period in European history. The great trade networks that linked the cities of Italy with the Hanseatic ports of the Baltic, that connected the markets of the Levant with the wool merchants of England, that moved silk and spices and grain and finished goods across continents and seas, also moved pathogens. The Black Death reached Europe via the Silk Road trade routes from Central Asia, arrived in Sicily on merchant ships from the Black Sea ports, and once arrived, it spread along the same commercial networks that connected the cities of medieval Europe, moving from port to port along river valleys, across mountain passes, following the arteries of trade. The mobile foraging band, by contrast, moved within a territory that was largely their own. Their contact with other groups were periodic and episodic, occurring at the seasonal gatherings that brought different bands together for social and ceremonial purposes. These contacts could and did transmit infectious diseases. Archaeological and genetic evidence shows that prehistoric foraging groups were not biologically isolated from one another, and that pathogens could spread through networks of foraging bands. But the speed and scale of transmission was incomparably slower and more limited than the explosive spread made possible by the dense, interconnected trade networks of the medieval world. The pathogen that entered a small foraging band encountered a community of perhaps 30 people before exhausting its supply of susceptible hosts or burning itself out through mortality. The pathogen that entered the medieval trade network encountered millions. The role of domestic animals in the medieval city's health picture deserves one more careful look, because the relationship between medieval urban people and their animals was even more intimate and biologically consequential than the general picture we have already examined. In a medieval city, animals were not confined to the periphery of human life. They were woven into its fabric. Cattle and pigs and sheep were driven through city streets to market and to slaughter. Horses provided the primary means of transportation and pulled the carts that moved goods through urban streets. Chickens and geese and ducks were kept in urban yards and even within buildings. Dogs, which served as guardians, hunters, and scavengers, moved freely through the city's spaces, and in the poorest urban dwellings, animals and humans often shared the same enclosed space, particularly in winter when the animal's body heat provided a meaningful contribution to the warmth of the dwelling. This intimacy with domesticated animals had direct health consequences through pathogen transmission. We've already noted the relationship between animal domestication and the emergence of human infectious diseases over the long sweep of history. But in the medieval city, this relationship was maintained in its most intimate form on a daily basis. The crowded market where cattle were sold and slaughtered was also the space where children played and merchants conducted their business. The stable where horses were kept was often adjacent to, or beneath the rooms where people slept. The mixing of animal waste with human waste in the streets and courtyards of the city created a rich substrate for the amplification and transmission of zoonotic diseases, diseases that can pass between animals and humans. Anthrax, transmitted through contact with infected cattle or their products, was a documented hazard of medieval urban life. Various forms of livestock disease that could cross the species barrier posed risks to people who worked with animals or consumed their products. Rabies, transmitted by the bites of infected dogs was a genuine and feared danger in a world where large populations of free-roaming dogs were an integral part of urban life, and the general background of zoonotic transmission, the constant low-level exchange of pathogens between the dense populations of humans and animals sharing the urban space created a biological environment that was, from the perspective of the human immune system, extraordinarily taxing. The Paleolithic hunter, who also lived in close contact with animals through this act of hunting and the processing of game, faced a different version of this zoonotic challenge. Hunting wild animals does involve exposure to their pathogens. Archaeological evidence suggests that various animal diseases have made the jump to human hosts in the context of hunting and butchering. But the scale and frequency of this exposure was very different from the conditions of the medieval city. The hunter encountered individual wild animals periodically and processed the open air. The medieval city dweller was surrounded daily by large populations of domesticated animals crowded into limited spaces that accumulated waste enriching the pathogenic environment of every surface and water source. The biological burden of zoonotic exposure was qualitatively and quantitatively different. We should take some time to consider what the experience of aging was like in these two very different biological environments. The human body's aging process is itself shaped by evolution, and the trajectory of biological aging is influenced profoundly by the accumulated stresses and nutritional inputs and disease exposures of a lifetime. In the Stone Age forager who survived childhood, the aging body still had access to the nutritional and physical and social inputs that maintained biological function. An older forager who could no longer participate in the most physically demanding aspects of band life was still part of a small, intimate community that provided food and social support. Their accumulated knowledge of the landscape and its resources, of the medicinal plants, seasonal movements of game, and the locations of water in dry seasons was enormously valuable to the group and would have been recognized as such. The social value of older individuals and foraging societies is well documented by anthropological studies of contemporary foraging groups and would have been a feature of Paleolithic bands as well. The older person in a medieval city faced a very different trajectory. If they had survived to old age, they had done so through a combination of biological resilience, relative social advantage, and luck. Their bodies bore the accumulated marks of a lifetime of nutritional deficiency and infectious disease and physical labour in conditions often unfavourable to musculoskeletal health. Their immune systems, taxed by decades of chronic challenges, were less capable of mounting effective responses to new infections. Their joints, worn by years of labour and postures poorly suited to the human skeletal design, were often arthritic in ways that reflected not simply the normal ageing process, but the specific biomechanical stresses of medieval occupational life. Medieval skeletal samples from older individuals frequently show patterns of degenerative joint disease that are more severe and more widespread than those seen in forager populations of comparable estimated age, and the social position of the medieval urban elderly was often precarious in ways that compounded their biological vulnerability. Without the family or guild connections that provided economic security, an older person in a medieval city could easily find themselves destitute, dependent on the charity of ecclesiastical institutions that were often overwhelmed by demand. The social safety net of the medieval city, such as it was a patchwork of religious charity and guild support and family obligation that left enormous numbers of people, particularly the urban poor and particularly women, without adequate support in old age. The social isolation and economic precarity of the medieval urban elderly were themselves biological hazards, working through the pathways of chronic stress and nutritional inadequacy to accelerate the biological deterioration of aging. The foragers' old age, while certainly not free of physical challenge, was embedded in a social structure that provided ongoing food sharing and social support as a matter of course. The small band's survival depended on the contributions of all its members across the full spectrum of age and ability, and the social norms that supported the elderly and the disabled were not merely altruistic, but practically adaptive. A band that cared for its elders benefited from their accumulated knowledge. A band that abandoned them lost the most irreplaceable repository of experiential wisdom in a world without written records. There is something quietly profound in this comparison. The two worlds we have been examining throughout this story, the dispersed mobile world of the Stone Age forager and the dense, complex world of the medieval city, were separated by tens of thousands of years of cultural development. And yet the one that was richer in culture, more complex in its social organisation, more capable of producing lasting monuments and written records and accumulated knowledge, was also the one that provided a significantly worse biological environment for the human bodies that inhabited it. The cultural achievement came at a biological cost, and the biological cost was, for a very long time, invisible to those who paid it, because they did not have the conceptual tools to see it clearly. The germ theory of disease, the understanding that infectious diseases are caused by microscopic organisms that spread through contaminated water and air and direct contact, was not developed until the 19th century. Before Louis Pasteur and Robert Koch and John Snow and the other scientists who established the microbial basis of infectious disease, the medical understanding of why cities were so deadly was limited and largely incorrect. Medieval physicians and natural philosophers offered various explanations for urban disease. Bad air, miasmas arising from rotting organic matter, was the dominant explanatory framework for centuries. The idea that certain configurations of celestial bodies predisposed populations to disease was another common element of medieval medical thinking. Divine punishment for sin was always available as an explanation for unexplained mass mortality. None of these frameworks, while sometimes pointing toward genuinely important environmental factors, like the bad air of poorly ventilated spaces, provided the understanding needed to actually address the biological causes of urban disease. In this sense, the medieval city was not simply unlucky or simply badly designed. It was operating in a state of profound ignorance about the biological mechanisms that determined health and disease. The people who built and governed medieval cities were not indifferent to health. Medieval municipalities enacted regulations about the disposal of waste, the location of slaughterhouses, the quality of food sold in markets. Medieval physicians prescribed treatments and preventive measures. Monasteries maintained gardens of medicinal herbs and provided care for the sick in their hospitals. All of this represents a genuine effort within the conceptual framework available at the time to address the health burdens of urban life. But the conceptual framework was so fundamentally incomplete that many of these well-intentioned interventions either had little effect or in some cases made things worse. The treatment of plague, for example, involved various measures including the isolation of the sick, which was genuinely effective, but also the killing of cats, which were mistakenly associated with witchcraft and disease, while in fact cats were the primary predators of the rats that carried the plague-infected fleas. The medieval cities that killed their cats in response to plague outbreaks may have actually worsened their rat populations and therefore their flea populations, and therefore their plague risk. This is an extreme example, but it illustrates the fundamental problem. Without an understanding of the actual biological mechanisms of disease, even well-intentioned interventions could go wrong in ways that were invisible to those undertaking them. The Paleolithic forager had no germ theory and no formal medical system, but their behavioral adaptations, shaped over millennia of natural selection, included practices that reduced their pathogen exposure in ways that were effective even without conscious understanding of the mechanisms. The tendency to move away from a campsite when it became contaminated with waste, driven by the simple sensory cue of smell, was an effective if crude pathogen avoidance strategy. The social customs around the handling of the dead, which appear to have involved various forms of disposal and avoidance in many foraging cultures, reduced the risk of post-mortem infection transmission. The forager's lifestyle incorporated this evolved behavioral pathogen avoidance naturally, without any formal medical knowledge, because they had been shaped by selection pressure over thousands of generations. As we draw toward the end of this long meditation on the relationship between civilization and biological health, it is worth reflecting on what the medieval experience tells us about the nature of human adaptability. The human species is remarkable among animals for the degree to which it shapes its own environment rather than simply adapting to existing environmental conditions. This capacity for environmental transformation is the source of everything we value about human civilization. But it also creates a particular kind of vulnerability that no other species faces in quite the same way. The vulnerability of creating environments that outpace the evolutionary adaptability of the bodies that must inhabit them. Evolution operates on timescales of thousands to millions of years. Cultural change operates on timescales of decades to centuries. This asymmetry means that whenever cultural change is rapid enough to substantially alter the biological environment in which human bodies must function, the bodies in question are likely to find themselves in a state of biological misfit with their environment. The agricultural revolution was one such rapid cultural change. The urban revolution was another. And in each case, the human body, which could not evolve rapidly enough to adapt to its new environment, suffered the biological consequences of that misfit in the form of elevated disease burden, nutritional deficiency, and shortened healthy life. The remarkable thing about the medieval period, seen from this evolutionary perspective, is not that people are unhealthy. Given the biological environment of the medieval city, it would have been astonishing if they were healthy. The remarkable thing is that they managed to maintain and develop a civilization of extraordinary cultural complexity and achievement, despite the biological burden they carried. The cathedrals that still stand in the cities of Europe were built by people many of whom were suffering from iron deficiency, anemia, and vitamin D deficiency, and chronic parasitic infections and the long-term immunological consequences of repeated infectious illness. The illuminated manuscripts that preserve the intellectual achievements of the medieval period were written by monks whose bodies bore the marks of tuberculosis and intestinal parasites, and the skeletal deformations of childhood nutritional deficiency. The legal codes and theological systems and philosophical traditions that constitute the intellectual inheritance of the medieval period were developed by minds that functioned despite, not because of, the biological environment in which they lived. This is, in the deepest sense, a testimony to the resilience of the human spirit, not in any vague or sentimental sense, but in a precise biological and psychological sense. The human nervous system, even when operating within a body compromised by chronic disease and nutritional deficiency, retains a remarkable capacity for creative thought, social organization, cultural production, and the generation of meaning. The achievements of medieval civilization were not made possible by favorable biological conditions. They were made possible despite profoundly unfavorable biological conditions, by the sheer cultural and cognitive momentum of a species whose capacity for symbolic thought and social complexity transcends the limitations of any particular biological environment. And this perhaps is the final and deepest lesson of the comparison between Stone Age and medieval health. The human species is defined by a tension between its biology and its culture, between the ancient body shaped by millions of years of evolution and the cultural worlds that body creates and inhabits. The Stone Age forager lived in a world where this tension was minimal, where the body and its environment were closely aligned. The medieval city dweller lived in a world where this tension was perhaps at its historical maximum, where the cultural world had raced so far ahead of biological adaptation that the body was paying an enormous price for the cultural achievements it was helping to build. We live today somewhere between these two poles. The modern world has used the cultural tools built during those centuries of biological suffering to dramatically reduce the misfit between the human body and its environment. Clean water, sanitation, vaccines, antibiotics, nutritional science. These are the products of the long cultural project that ran through the suffering of the medieval city. But the tension is not fully resolved. The modern body sitting in its climate-controlled office under artificial light, eating processed food, breathing the air of urban environments still laden with particulate matter, sleeping with its circadian rhythms disrupted by screens and artificial light, is still not in perfect biological alignment with its evolutionary heritage. The conversation between the Stone Age body and the modern world is still ongoing. Perhaps the most appropriate response to this long, slow history of biological misfit and eventual partial repair is not triumph or despair, but something closer to humility. Humility about the biological cost of the cultural achievements we inherit. Humility about the degree to which the modern world has solved the problems that made medieval cities so biologically devastating. And humility about the degree to which the biological legacy of that long period of misfit, the evolutionary pressures and adaptations and vulnerabilities shaped by thousands of years of urban life, still inhabit the bodies we carry through the modern world. The bones speak if we learn to listen. The dense bones of the Stone Age forager move through open landscapes under open skies, fed by the diverse bounty of natural environments, speak of a body functioning close to its biological optimum in a world for which it was evolved. The marked and thinned and lesion-riddled bones of the medieval city dweller speak of a body struggling heroically to maintain itself in conditions for which it was not designed, in service of a cultural project that would eventually produce the knowledge to repair the damage. Both sets of bones are part of who we are. Both speak to the extraordinary complexity of the human story. The story of a species that has always been simultaneously both more and less than its biology. The night deepens. The sounds of the city outside soften to something almost like the sounds of wind across a savanna. And in the quiet, the old bones and the old knowledge settle into their places, speaking in the slow language of evolutionary time, reminding us of what we were and what we have become and what perhaps we're still in the process of finding our way toward. A kind of health that honours both the ancient body and the modern world it must inhabit, a civilization that builds not against its biology, but, at last, with it. There is one final thread that deserves to be drawn out before this story rests. It concerns the relationship between pain and knowledge, and the particular way in which the medieval city's biological suffering contributed, over centuries, to the development of the understanding that would eventually make cities genuinely healthy places to live. The suffering of the medieval city was not in vain. It was, in the most uncomfortable and morally complex sense, educational. Not in any way that the people who suffered could have recognised or consented to, but educational in the long retrospective sense that the observations made by physicians and natural philosophers and ordinary people about what made people sick and what made them well gradually accumulated into a body of knowledge that, combined with the insights of the scientific revolution, eventually produced the germ theory of disease and the public health reforms of the 19th century. Medieval physicians working within the framework of Galenic humoral medicine were not passive observers of the suffering around them. They were active inquirers, documenting what they saw, attempting to identify patterns in who got sick and who did not, trying to understand the relationship between environmental conditions and disease. The miasma theory of disease, which attributed illness to bad air arising from rotting organic matter, was wrong about the mechanism but right about the observation that certain environmental conditions were associated with elevated disease rates. The medieval intuition that air quality mattered, that proximity to waste was dangerous, that certain seasons and certain locations were more dangerous than others, was based on genuine empirical observation, even if the theoretical framework used to explain those observations was incorrect. The same was true of the medieval understanding of contagion. By the time of the Black Death, the idea that certain diseases could spread from person to person through some form of direct or indirect contact was widely accepted, even if the mechanism was not understood. The isolation of plague victims, the cordon sanitaires established around infected cities, the quarantine of ships arriving from infected ports, all of these public health measures were based on the empirically grounded, if theoretically incomplete, understanding that plague could spread through contact and movement. They were imperfect and often socially devastating, but they were rooted in genuine observation, and they were, in many documented cases, effective at slowing the spread of plague. This accumulation of empirical observation, however theoretically confused, was the raw material out of which the understanding that eventually made cities healthy would eventually be built. The physicians and chroniclers who documented the relationship between urban filth and disease, the administrators who enacted regulations about waste disposal and food quality, the engineers who designed and maintained the rudimentary water systems of medieval cities, all of these were contributors to a slowly growing fund of practical knowledge about the relationship between environment and health. They were doing so within a conceptual framework that was fundamentally inadequate, but the observations themselves were real, and they survived in written records that later generations could use. The great demographic catastrophe of the 14th century, the famine and the plague that together killed perhaps a third of Europe's population, had an unexpected cultural consequence. It disrupted the social hierarchies and intellectual traditions of the medieval world in ways that opened space for new forms of inquiry. The enormous mortality of the Black Death killed not only ordinary people, but scholars and physicians and theologians. The intellectual communities of medieval universities were devastated. And in the aftermath of this devastation, the survivors found themselves in a world that felt less fixed, less determined by the certainties of tradition. This is one of the historical contexts in which scholars locate the intellectual ferment of the Renaissance and eventually the scientific revolution, the cultural movements that would eventually produce the conceptual tools needed to understand and address the health crises of urban life. There is something philosophically vertiginous about this observation. The same biological conditions that made the medieval city so devastating to its inhabitants, the conditions that we have been examining throughout this story, the contaminated water and crowded living and nutritional deficiency and epidemic disease, also created the cultural conditions for the eventual development of the knowledge that would address them. The suffering generated the observation. The observation generated the knowledge generated the remedy. This is not a comfortable narrative, and it is not meant to justify or minimize the suffering of the people who lived and died in the biological crucible of the medieval city. But it's a real feature of the historical process, and understanding it is part of understanding how the human story has actually unfolded. The Stone Age forager, living in biological conditions more closely aligned with the body's evolutionary design, did not generate this kind of intellectual pressure toward the understanding of disease mechanisms. There was no Black Death to disrupt the intellectual traditions of a static society, no epidemic catastrophe to generate the urgent need for new explanatory frameworks. The health of the foraging lifestyle, paradoxically, did not need to be understood in order to be enjoyed. It was simply the natural consequence of living in a world to which the human body was well adapted. The medieval city, precisely because it was so biologically hostile, generated the intellectual urgency that drove the development of the knowledge needed to eventually make it livable. This is one of the deepest and most counterintuitive insights that emerges from the long comparison between Stone Age health and medieval health. The biological regression of the medieval city was, in a very long-term historical sense, part of the path toward the biological improvements of the modern world. The path from the clean bones of the Stone Age forager to the long, healthy lives of the modern, well-nourished urban dweller ran directly through the suffering of the medieval city. It could not have been otherwise, because the cultural tools needed to make the city healthy were tools that could only be developed within the context of urban civilization. And urban civilization, in its pre-industrial form, was necessarily a context of biological challenge. As the mind drifts in the late quiet following these long threads of biological and cultural history, what comes into focus is not a simple lesson or a single takeaway, but something more like a texture of understanding, an appreciation for the extraordinary complexity of the relationship between the human body and the human world. The body that sits or lies here now, reading or listening, is a Stone Age body. It carries within it the evolutionary heritage of hundreds of thousands of years of foraging life. And it also carries within it the biological marks of 10,000 years of agricultural civilization and 5,000 years of urban life. These accumulated adaptations and vulnerabilities and disease resistances that those long millennia of biological challenge have written into the human genome. The medieval city lives in us, in a sense. The immune adaptations that survived the plague, the genetic variants that conferred resistance to tuberculosis and are now common in populations with long histories of urban living. The metabolic flexibility that allowed some individuals to survive on grain-dominated diets. All of these are part of the biological inheritance that the medieval biological crucible bequeathed to the modern human body. We are not the same as the Stone Age forager. biologically speaking, even though we still carry the deep evolutionary architecture of the foraging life. We have been shaped by everything that happened in between, by the agricultural revolution and the urban revolution, and the epidemic catastrophes, and the slow accumulation of nutritional deficiency, and the eventual development of the knowledge that addressed it. This is the story of what we are, told through the slow language of bone, pathogen, and evolutionary time. It is a story that could only be read retrospectively with the tools of modern bioarchaeology and evolutionary biology and historical epidemiology. It was invisible to the people who lived it, because they did not have the conceptual tools to see the pattern in which their individual lives were embedded. They lived the story without knowing the story. They suffered the biological consequences of the medieval city without understanding the evolutionary mismatch that made those consequences so severe. They built the cathedrals and wrote the manuscripts and developed the legal codes and maintained the trade networks without knowing that their bones were recording, in the language of lesion and decay and density, the biological price of their cultural achievements. Now we can read that record. Now we have the tools to see, in the comparison between Stone Age bones and medieval bones, what the long arc of human health has actually looked like. And what we see is not a simple story of progress from worse to better, but a complex story of biological trade-offs and cultural achievements and biological costs and eventual partial repairs. A story that is still being written in the bodies of people living today, in every city on Earth, still negotiating the ancient tension between the Stone Age body and the modern world. The darkness is full and quiet. The bones rest in their museums and their carefully excavated sites and their ancient soils. And the story they tell, the long slow story of the human body moving through the human world, continues in every sleeping body tonight, in every heartbeat calibrated by evolution for a world that no longer exists, in every immune response trained by millennia of biological challenge to navigate a world that is always, in some fundamental sense, still finding its way back to health.